second in a series of volumes by revolution, I guess. It's called Slices and Shells 2. The first video was called Slices and Shells 1. Now, in this particular video, we'll be looking at, rotating an area, the same as before. The area trapped between the square root of x and y equals x cubed between 0 and 1, but we're not going to rotate it around an x or y axis. We're going to be rotating it around lines. Basically, x equals 2 and y equals 2. And I'll show you what this looks like in a minute. But again, we start off by the same ideas. We generate, if you like, volume seeds, and then we grow the volume from the seeds. Depending on whether it's a slice or a shell, we'll obviously need to look at changing the radius in this case. So let's actually have a look at what we're going to be doing. Okay, so let's just have a quick look here. Now, I'll just actually generate these again. Okay, so we're starting with this little area. Let's actually we can see here now, just generating the volumes of solid revolution. Here we go. Okay, alright. So these are now, the little one is obviously the one we were doing before. That's around the x-axis, and this now is the larger one is around a line. Now, I'll just quickly show you as I move it. We're going to be looking at 2, so I'll just bring it across here to 2. Okay, so we're going to be looking at rotating that area around the line. In this case, this is going to y equals 2. That would be y equals 2. So let's just have a quick look. So this is, you can see here, a much bigger volume. Okay, and in this case, depending on where we are, let's have a look. You can see here, this is sort of rotating around the lines in different spots. But we're going to be, in particular, looking in this series in x equals 2 and y equals 2. Okay, so you can read through there, but it's very much similar to the one before. Okay, now again, this is basically just explaining what we're doing. We're looking at this area again as we did before, and we're going to now look at the lines x equals 2 and y equals 2, rotating that particular area. Okay. Now, as you know, depending on where you put the bar, obviously in this case, if you have a look at it there, it's actually parallel to the y-axis, and it would actually have thickness delta x. Okay, because if we move it through the x, basically you can describe out shells or slices depending on which axis you are rotating around. Okay, we're going to start off by looking at rotating around y equals 2. Now, there are a couple of things we need to know. Obviously, let's see if we can get these pens to work. There we go. Well, first up is these things. These are the important things, the radiuses. That's a little radius, and this is a big radius. Now, the big radius obviously is bounded by this function coming up here, which is y equals x cubed. And the little radius here, you can see here, is bounded by this function, which is the square root. Okay. So we need to now, and you can see here, it's line y equals 2. So those radiuses are right, 2 minus, for the big one, 2 minus x cubed, and for the little one, 2 minus the square root of x, or x to the power of half. And if we're going slices, we know we've got big R squared minus little r squared. They're going to be sort of washers. Okay, when we rotate them around, let's actually have a look at that. Okay, here we have the slice about this line y equals 2, and I'll just move the slice just to show you. These are the slices, obviously. Here we go, bigger slices, washes. Okay, here we are. Okay, now what I'll do now is I'll just put the trace on for the surface, and then I'll try and we'll try and scribe out this line. Okay, so let's have a quick look. I'll do this too quick, and it makes it fairly rough. So if I do it nice and slowly, here we are. Okay, so this is now let's have quite a little bit of a look at this. This is now Okay, let's go have a look. This is the shape. Okay, let's go big sort of bowl, I suppose. And we're going to be trying to find the volume, okay, of this particular shape. Okay. Let's see here. Geogebra 5. It's quite powerful. Okay, well, we can slicing around y equals 2 will generate this big bowl shape. You can see here we're going to need to basically get the big r and the little r, and then we can actually do a bit of, sometimes difference of two squares can help us sometimes, help us with the algebra. Okay, let's see what happens. Okay, here we go. Now, again, as I did before, we just put the bar, the black bar, which is actually, you can see here, it's perpendicular to the x axis. It's going to have a thickness of delta x, and the volume C is just the washer formula, basically. Pi big R squared minus little r squared times the width of the bar, which in this case is delta x. And you can see here I've done a little bit of algebra, and we need to just be careful. We do always need to adjust the radiuses. Okay, you can see here I've actually adjusted the radius, and over here this radius here. Obviously, when we do the calculations, it's going to impact obviously on the algebra. So and okay, if you go back to the previous one, we've actually did that calculation before, and you can see here I've just evaluated that, expanded it, integrated it, and evaluated between 1 and 0, okay, which is where this, the bar is moving actually along the x-axis through that particular area, okay, from x equals 0 to x equals 1, okay, and we'll get 55 pi on 42 cubic units. Okay. Okay, now we're going to do a slice around the line x equals 2. Okay, this is going to basically, obviously the other direction of the line x equals 2. And let's actually have a quick look at the slice around x equals 2. We're going to now look at the slice around the line x equals 2. You can see here, I'll just move that line anyway just to show you, obviously depending. We're going to look at actually particular 2. I'll just try and get that on 2. Okay. Now, this surface you can see here is rotating around that line. We've got the bar in, AB is in now, and you can see here it's it's perpendicular to the y-axis or parallel to the x-axis. Okay, so if I move this, you can just see here are the different slices. Okay, I'll just move it up a bit. Okay. Okay, so we can actually, I'll put the trace on for the surface, and we'll try and scribe out this shape. So let's put the trace on, and I'll have to do this reasonably slowly to scribe out the shape. Okay, let's try and scribe it out. Okay, that's the trace on for the particular slice, and we'll just have a quick look at it. Okay. Now in the notes it's actually a red slice, but change it to blue, and as I said, if you go back and have a quick look, you can see the slices as we go around the angle there. Okay, the individual slices, and you can see here the shape's made up of lots of slices. Okay, rotating around that line, x equals 2. Okay, well let's go back to the, we'll actually calculate this one. I'll just try and get this to go here. Well, okay, let's have a look at the actual radiuses. You can see here now. I'll try and get the pen to work. It's actually, okay, now. Okay, that's the big radius and the little radius. It's here. Now, you'll see the bar. The bar is actually. Sometimes you can make this bigger. The bar along here, okay, has thickness of delta y. Okay. Now, okay, so delta y. So we're going to need our radiuses in terms of y instead of x. Okay, so just a few adjustments need to be made. Okay, you need to rewrite the functions as in fact functions of y, which are functions of x at the moment. Rearrange them and get the radiuses. You can use the difference of two squares again. And you can see a bit of algebra. You might have to expand that out. Okay, and you can see here, eventually we'll basically be able to get the answer as I think it's supposed to be, it's supposed to be 19 pi on 15. Hold on. Okay, it's 19 pi on 15 should be the answer here. I left off the one in the denominator there. Okay, I'll just fix that up. Okay, so let's go on now. The next one we're going to be looking at shells. So we're going to start doing some shelling, and you can see here shelling about the line y equals 2, and you can see here that the shell will be formed by this. You can see the bar AB. Now it's going to be parallel to the axis of rotation. In this case, it's going to be parallel to the line y equals 2, and we're going to need to look at the radius. Now the radius, if you have a quick look here, is just 2 minus the height of the bar, which is its y value, so it's 2 minus y. Okay, the height of the cylindrical shell, which when flattened turns into that rectangular prism, is just the length of AB, which is the difference in the two functions. Now it's going up y again, so we need the functional values in terms of y as well. Okay, so you can see here we're going to need to do some rearranging functions, x functions of y, and just having a quick look at the heights and the radiuses. Well, okay, let's actually have a quick look at the shell around the line y equals 2. Okay, here we have the shell around the line y equals 2. You can see I'll just move it up and down. Here we go. This is the shell. Okay, and as I said, we're just doing line 2 at the moment. Okay, so these are shells. Okay, so what I'll do now is we'll just put the trace on for the particular surface. Okay, and I'll now just try and generate the volume. Let's have a quick look. Okay, now, so let's have a quick look. Now as we come around here, we should be able to see the shells roughly. You can see them slightly a little bit there. Okay, just not too bad. Okay, let's try and get this to, you can have different views. You can actually have a look at this with different views as well. Oops. Okay, let's go home. Okay, just rotate it around here. Whoa. The shells actually, depending on how you align these planes in. Okay, alright. Okay, so let's see if I can get this to go back to home view. Okay, let's try and get back to home view. Here we go. Okay, alright, so let's have a look at the maths of this. Okay, so here we have, you can see here, this is the shell around the line y equals 2. Okay, that means now with shells, as you know, the volume element, 2 pi r h delta y in this case, okay, because we are moving the shell up the y-axis. Okay, it's around that line y equals 2. Okay, so you can see here that the height is the actual length of the bar. Okay, which is the functions of y, and the width is obviously delta y, and the radius. Now the radius, as I was saying before, is actually just 2 minus y, and you need to obviously multiply these, expand the brackets if you like, and work out the volume. Okay, which is going to be, you can see here, 55 pi on 42. Okay, so very similar to before, just have to watch the radius, I guess you could say. Okay, so let's move on to the last little section here. We're going to do some shells around the line x equals 2, and you can see here the bar is actually now, okay, it's going to be parallel to the x equals 2, and then you can see it's going to have a width of delta x because it's moving along the x between x equals 0 and 1. Okay, we have functions of x. The radius now is just, okay, what is it going to be? Well, it's 2 minus the x value, yes, and the height is just, okay, the difference in the height and the function values. Okay, the top height you can see is root x, and the bottom height of the bottom of the bar is actually x cubed. And obviously the height is just the difference of those two functions. And you can see the volume element again, 2 pi r. Okay, because it's a shell, remember it's a rectangular prism, 2 pi r h delta x. And you can just have to look at this. We're going to have a look at some calculations in there, but let's actually just try and scribe out this one as well. Well, okay, here we have the shell around the line x equals 2. Let's actually just move the shell. Okay, let's look at moving the shell. Here's the shell. Now, you can see here the actual bar is moving along the x-axis from 0 to 1, has a thickness of delta x. Okay, so it needs to be functions of x in the integration. So we'll see this in a minute, but let's actually just try and scribe out this shape. I'll just put the trace on, and we'll just do this slowly. Okay, here we go. Okay, let's actually just rotate it around. Let's look at the shape. Okay, you can see the shells. If we go around here, you can just see the whole series of shells there. Okay, yeah, it's a bit like another bowl. Okay, and let's actually let's look at some different. Okay, aspects. You can actually have a quick look and all these different sides. And actually, okay, here's our bowl. Right, let's actually have a look at some of these calculations involved in this. Okay, we've done a few before, you can see here. Okay, here we go. You can see here the bar is parallel to the axis of rotation, in this case x equals 2. Okay, bridge cylinder formed, yes, okay. You can imagine this is, well, the radius needs to be adjusted slightly, which, as you know, is 2 minus x in this case. And the height, which is the length of the bar, CD. Okay, you can see here as functions of x. You need to multiply this out and obviously integrate each of the parts and evaluate it between 1 and 0 and the x bounds. Okay, and you can see here again our answer is 19 pi on 15. Okay, it shouldn't actually matter whether you do slices of shells around x equals 2 or y equals 2, you should get the same answer. The volume is obviously the same. Okay, well, thank you for watching, and bye for now.